And I'm really proud to have a colleague now with me here on stage who will bring you the SPE technology a little bit closer, because Matthias is really, we would call it early adopter. Yeah? So I think there are not that many people globally right now who has such a long history with SPE already, such a deep knowledge with single pair Ethernet right now, and also like formed this technology to make it suitable for industry use cases that much. So Matthias, I'm really happy that you are here. Warm welcome on our stage, and please enjoy Matthias' words. Thank you.
Yeah, thanks for the warm introduction, Kilian, and I'm happy to stay here today. And I have a strong statement with me of the topic of my presentation, SPE, so single pair Ethernet, game changer and enabler of IIoT. So it's really a strong statement, and during the morning session I will give you some more information why this could be true, and I hope you learn something about it. So let's start with this picture. Some of you will say, okay, I know this picture, I see it very often. Yes, we have this picture about 20 years. And I'm personally learned it the first time if I jump into this business in my business career around 2000, so 20 years ago. In this time, most of the controller networks are connected not with Ethernet. We use field bus systems here. And in the lower level, with all the sensors, we use analog and digital sensors. And around 2000, 2003, the first time Ethernet jumps into the market with Profinet, EtherCAT, and all these other systems. And it was very nice also for me over the whole business life that I have the chance to work with my colleagues here to bring Ethernet really as an automation system in the market. So today, Ethernet is dominated with Profinet, EtherCAT, and others, the control level, and we have it also back to the field level with all the drive and motion control and vision. But still, we have a big gap for Ethernet communication in the field area. Here, still, we have analog sensors, bus systems, and so on. And to fill this gap, single pair Ethernet is definitely the nice technology, because, as the name says, it works with one pair of wires, and it's very simple. Yeah, some of you also may say wireless is a nice technology too. So we talk a lot of 5G at the moment, and I agree. Yeah, for all wireless applications and mobile applications, wireless is a nice topic. But how to bring power to the devices, especially if you talk about actuators, drives, and so on. And for this, cable is still the best solution. And that's why at next, I want to have a short and detailed view with you to the used cable. Yeah, as I mentioned at the beginning, we have field buses here, Profi pass cable, 2 wires inside, very simple. And when we jump around 2003 to Profinet, EtherCAT, and others with fast Ethernet, and you see here already, we need 1 pair more. So instead of 1 pair, we have 4 pairs. But this is the standard today. It's good enough from the speed, it's easy to install, it's robust, and it's working. More and more applications also request gigabit, but for gigabit, instead of 2 pairs, you need 4 pairs, and then it becomes more complicated. Yeah, if you use ready-to-install cables and produced inside the factory, it will work. But to install such cables outside in the field, it's really a challenge. And if you look now with the new technology we have available coming from the automotive industry mostly, we have only 1 pair. And I guess if we have the situation 20 years ago with 1 pair and gigabit communication up to 10 gigabit, I guess we want to jump directly to this. But now we have the chance to do it. Okay, let's have a look how single pair Ethernet can be integrated to the market. What will be the strategy? In the past, we see the Ethernet communication or the communication, the new structures come from the top level to the down level. Now we have this gap for Ethernet communication in the field level, and that's why the strong request will to start with single pair Ethernet in the field level. And if you look to the market, we have already systems coming from the process industry with this name APL, Advanced Physical Layer, they will use single pair Ethernet with some modification and adaptation for the process industry very soon, and it will come in this way. So that's why we will see it will start in the field level, and later on, if the market is big enough and the cost goes down, it will go step by step also to control level, and we will have it for new systems in the future also in higher levels. But as we know, single pair Ethernet is a new physical layer, and besides the cables and connectors, there's much more behind. And for this, I want to share this picture with you, what shows the single pair Ethernet ecosystem. Yeah, an ecosystem, you know it very well from the nature. For an ecosystem, it is working well. Every component must be working. It must be working together, each component with the others. And the same we need also for Ethernet, especially for single pair Ethernet as a new system. What we see in the center of this picture, it's the technology itself. So this technology was, in this case, developed by the company Broadcom under the name ProdaReach as a single source solution. And to bring it really to in a wide range of applications and to the market, a huge number of standards are created around it, because only with standards, many companies have the chance to jump in this business and build all the products that works very well together. The next level is the component level, where you see all the single components you need to integrate the technology into your own device. And we will see some more information also later on in the next presentation, how you do it in detail. So what we need here is that, of course, the semiconductors. In this case, protocol drivers, so-called PHY chips. You need switching chips and some others. And then you need magnetics, so in between the magnetics, in between the semiconductors and the passive infrastructure, cables and connector, you have always magnetic components to have the galvanic isolation and to realize the filtering and EMC protection. And then, of course, this is a main work of HARTING, connectors, cables, and cable systems, patch cables, and so on. And last but not least, also the active network components like switches, media converters, and also the testing equipment. If this is available, you can integrate this new technology to different devices like sensors, controllers, frequency controllers, and others. And this technology can be used in a wide range of applications. What we see here, all these applications coming up from smart cities, energy control, traffic control, but also our focus, all kind of automation applications, robots, and so on. But nevertheless, also in mobile applications, so we call this as HARTING as mobile machinery, like agriculture machines, mining machines, and others. So this ecosystem shows you what it's needed, and what you see also here, it's a big job for many companies. But before we look a little bit more in detail to the ecosystem again, let's have a short jump also to the standardization. This picture shows very good the protocols coming from IEEE, the biggest engineering organization in the world, and also responsible for all aspects of Ethernet communication. So in the x-axis, you see very well the link length. So if you see it here, single pair Ethernet can go up to at least 1,000 meters, so 1 kilometer. And in the y-axis, you have the speeds. And what you see here also very clearly up from low speeds, 10 megabit, up to the very high speeds, 10 gigabit. We have already protocols available in the market. And what we also see, it's the main difference between standard Ethernet and single pair Ethernet. Standard Ethernet always works with 100 meters if you use copper cables. Here we have different lengths depending on the speed. And what we see as a little bit as a challenge that we have for the higher speed, just 15-meter channels and the 40-meter shielded channels. But also here, this gap is under evaluation. And very soon we will see also protocols covering 100 megabit up to 500 meter. And I guess also gigabit will be available because technically definitely is it possible. At the next picture, I want to give you a little bit an overview how these different standard organizations work together. So at the top, you see the IEEE with its protocols, and they have a very close relationship also to the cabling standard committees, in this case, ISO, IEC, and TIA for North America. This is not new just for single pair Ethernet. Such cooperation and this relationship between the standard organizations are available since Ethernet is existing. And important to know is this cabling standards are mostly developed in parallel with the protocol standards. So here many people work in both organizations, and there's a close exchange of information. The cabling standards are very important for you as users who wants to install cables on cable installations, and they make references, of course, to the cable they want to use. Also here, different cable standards are in place already for cables usable for 10 megabit, 1 kilometer, and the higher speeds, shorter lengths. And of course, also the connectivity. And if this main standard work is done in the IEEE, the different component standards and cabling standards, the way is free, or the way is open to implement this technology also to the industrial Ethernet user groups like the P&O for Profinet, and mainly also the ODVA for Ethernet IP. Yeah, then let's have a jump also to the most emotional component of this ecosystem, especially for us as HARTING, the connectors. And what we did here, with the long experience we had with with standard Ethernet, we created a completely new product range for single pair Ethernet. We started just from zero with a blank part of paper and developed everything new. What we see here, it's a range of connectors. We have an IP20 solution for inside the cabinet. And what we also did, we used this mating phase exactly the same and implemented to the very well-established and well-known waterproof and robust industrial connector systems. So small versions with an M8 size version, and here we're offering also different locking systems, very easy system with a snap-in for easy and simple sensor systems. Then the classical screw versions, because screw is the most often used system in the world and the customer and the market request with. And of course also our push-pull system where you connect and disconnect the connector very easily. In addition, especially also for the long-reach protocols with the bigger cables, and because M12 is the main standard today, more than 90% of interfaces in industry are M12, we're also offering the M12. And here also we're offering, of course, the screw locking and the push-pull locking. What we also see, if somebody implement the M12 to his devices, the device side component is always the same. And then the customer can decide later on if they want to use to connect this device, the M12 connector or the push-pull connector. What you see here also at the edge of this picture is the M8 hybrid. This is an additional connector, and hybrid means in this case we have one pair for data and one additional pair for power, and in this case we can deliver much more power, so it's an M8 power connector for 8 amps and 60 volts. This is much more with the so-called power over data line communication system, where we can also use the data wire to inject power remotely to the devices. And we will see later on an application also for this M8 hybrid. This standard was already published in 2020, and a second edition with additional corrections and adding features was published also last year. So that's really a stable standard, and we can see that we get products from HARTING and also from others in the market today. Nevertheless, also a short introduction how you make the cabling. As you mentioned, the main standard for the cabling international is the ISO IEC 11801. And maybe nobody has heard about it, but we all use it. If you select a patch cable today or wants to buy an installation cable, you know the categories Cat5, Cat6a. This is coming from ISO IEC 11801. And here we have different parts of this. For us in the automation, important is the industrial part, the -3. And you see here also the connection between the general installation of the network in your factory up to your production plant and so on. And then if we go inside the so-called automation island, what could be a machine, a production cell, or a robot, then we have also another standard as the IEC 61918, who describes how to make the installation inside machines. And very important for the end customer is what kind of connector you have to use. And in all these standards, both of this, and also in addition to the TIA standards now in preparation in North America, there is a strong recommendation and definition for the industrial style connector, the HARTING T1 industrial, according to the IEC 63171-6. This is very important for the market, that you have the definitions in the standards and the clear strategy and regulations how to install it. And that's why let's finish also with the standardization with a short overview. What you see here also, the protocols are available from IEEE, the different components standards are available, the cables and connectors, and of course also the cabling standards are available, and this brings the market and the customers who wants to use this technology to a very good position, because now everything is clear. So let's look to the next level, the component level. How is the situation on the component level? And definitely we have everything available what's needed. I personally did just last month evaluation about the availability of the semiconductors, and I found already public available on the different websites from the semiconductor vendors around 100 chipsets for single pair Ethernet. So they have chipsets for all speeds from 10 megabit up to 10 gigabit. This consists, of course, the protocol drivers, the so-called PHY chips, but also the first semiconductors with the switching chips, and the integrated PHYs are available. The next important components are the magnetics. As I mentioned, these are the core component to realize the EMC behavior of the systems and the galvanic isolation between the electronics and the passive infrastructure. And when you see this big range of connectors available, and also available now from HARTING, cables and connectors and cable harnessings, of course. And then we can jump into the active components, so switches and media converters are available. And also here, my colleagues will show you later on the real products we will launch. And last but not least, also the testing devices you see on the other corner. Testing devices are very important to produce the cable assemblies in the production plant, but also for the end customer who wants to use single pair Ethernet, have to install it, have to test everything before they start running, and to find failures if they are. Yeah, what you see here, this whole single pair Ethernet ecosystem is a lot of work. We as HARTING are one of the major players, but I want to point out there is something more behind. And here I want to introduce the single pair Ethernet industrial partner network, founded from HARTING together with 6 major players in the market around 2.5 years ago. And our main target with this network is to bring single pair Ethernet as technology really to the market. And here we need the power of all the members together to have a good marketing voice in the market, but much stronger also to produce and make available all the single components and the informations. What you found on our website, you found a lot of white papers, but very important also application notes. Yeah. If you look to standardization, nobody wants to read 100 pages of standards just about a cable. Yeah, at our website you found the application note, and at 7 or 10 pages you found everything what is needed. So it's also one of the goals of our foundation, to bring the information to the market and train the customers who wants to use it. Yeah, if you look here also again to the ecosystem, you see this huge number of companies working on all these different aspects. And we have also very close cooperation with the chip vendors, and that's why we know what is going on. And here you see really, not only from pictures, really all these components are available, so you can start with your own developments. And this is also a nice picture where you see where all these big companies and small companies are located in the world. And you see, if you look to the globe, we have in all major regions members of our foundations, and we are now 52 members, and the network is still growing. And what is also very nice to see, we have small members in our foundation and also the big players, and all this works very fair together. It was very exciting for me to see this and feel and can be part of this cooperation, because if you have a question, you found always in our network someone who will answer this, and together we make the vision real to bring single pair Ethernet as technology to the market. But nevertheless, all of what I show you here up to here, it's more or less theoretical and a strategy and vision. But what I have with me today is also a real application, because you can say, yeah, now you show me everything on the screen and so on. But here I bring with you a really working application. I'm very proud that I can present it in person for our partner Perinet. Perinet is a little bit related also to HARTING. We have a cooperation with the exchange of products, and Perinet is located in Berlin and owned and founded by our senior chef Dietmar Harting. So we work very close together. What Perinet did, they decided to use as technology, as protocol 100 base T1, so the 100 megabit solution. This is a big advantage because when we have enough bandwidth also for flexible network structures. Yeah, here you see again the M8 hybrid, because it's a very big advantage here to separate power and data, because doing this you can realize a lot of different structures, not only line structures, also you can build up tree structures and so on. You are very flexible in the setup of your network. So each of these IoT systems from Perinet starts with the so-called Peri-start. This is a gateway where you bring in standard Ethernet, in this case fast Ethernet and power, and when all the other connections are done with this hybrid system, you see it with the screen arrows over the system. Another important component in the system are the T connections, and these are not only simple passive connections, only the power is switched inside this connection passive. We have a switch inside, so we have really a switch network, and also this is a requirement to make it happen to realize different installation concept. And at the end, to connect standard sensors, you have the so-called Peri nodes, where you have the single pair Ethernet connections, a web server to provide the data to the network above, and also to connect different kind of standard sensors you can find in the market today. If you look to the product range Perinet is offering today, you see with a very small range of different components, such a single pair Ethernet sensor network, an IoT application is possible to realize. So we have at the beginning the Peri-start, this media converter to inject power and data to the hybrid infrastructure. So Perinet offers two versions, a flex version with cables and a standard version where you have connectors inside. Then also the Perinet switch with the power connection inside too, the Peri-line patch cables to connect all these devices, and then the different Peri nodes. And inside the Peri node, as I mentioned, there is a transition from single pair Ethernet to the different sensor protocols, like for example, analog sensors 0 to 10 volts, PTI 100 for temperature measurement, and also GPIO for general parallel input and output for digital sensors. What they also add now to this product range is a Peri-Mica edge computer. There is already single pair Ethernet interface integrated. And if you want to go to mass production, then of course the Peri node is not the optimal version. Then the Peri core module is offered, where you can put in the functionality of the Peri node to your own device. And doing this, you can, for example, build up such a test application where you have the Peri-Mica at the starting point where you can control and manage the data. Then you have the different infrastructure, and you can go here at the left side to a proximity sensor, and here on the upper side also for a PTI 100 temperature sensor. And in this way, you can also expand this network and can really create IoT solutions based on single pair Ethernet. So coming to an end for today and make a short summary, definitely single pair Ethernet is the technology we need in the market to make IoT possible. It simplifies the network infrastructure very soon. You don't need any gateways anymore, so you can do all of this with single pair Ethernet. You can provide data and power in one. in one cable. You can do it hybrid or with this power over data line system. And in this way, I hope you see single pair Ethernet is definitely the perfect infrastructure and the enabler to make IoT ready for automation. So thanks for your attention so far. And yeah, I will invite you also jump to the network website. You found more information also for this. And nevertheless, we are also happy to have you as a new member in our network. Yeah.
Thank you very much, Matthias. So it's a perfect ending here. Because we both also work together in the single pair Ethernet partner network, so that was a perfect place promotion. Thank you for that, Matthias. And I have, during your presentation, one question came up to me. How long is the story already? So I remember that you were coming back from an IEEE or IEC, I can't recall it, meeting one day, I don't know, it feels like decades ago when we first talked about SPE, to just show the people how long the story already is running and how long it will be in the future.
Yeah, it's an interesting question, and sometimes it feels like it was yesterday. But thinking back, the first time where I was attending IEEE was in Berlin 2015. But to going to IEEE in front, we have some discussion also internally, and I guess the first hint was coming up in 2014, end of 2013. In this time, it was named also reduced twisted pair or automotive Ethernet, but it was a long story, and was happy to work on it, and it was so much work behind it. The time is running so fast, and now we are standing here and can present real products, and it will work. Yeah.
Perfect. Thank you, Matthias. Thank you so much.